I'm Math Dad,
I'm Science Mom.
and today we're getting into some multiplication problems, talking about some fun algorithms and doing some story problems involving multiplication.
What is lattice multiplication?
Oh, patience, my young Padawan. We shall get there.
Okay.
But first, we've got to get to our warm-up problem. Looks like Science Mom was successful in solving.
I got nervous. I got really close to that timer trying to do a different approach that was not working at all. And then I realized we just need to do 6 plus 2, because 6 plus 1 plus 3 divided by 3 is 1 equals 8.
Exactly. 6 plus 1 is 8. Well done, Science Mom. I will note that I saw yet another way of doing it. What if we had done 6 minus 3 times 3, so that's 3 times 3, minus 1. That would give us 8.
Nicely done. I didn't see that one at all.
Or the other one I saw was if we did 6 divided by 3, that would be the number 2, right?
Yeah.
Okay, well we could multiply 2 by 4, and that would give us 8. So to get 4, we would do 3 plus 1.
And that uses all 4 numbers.
Oops, and that uses all our numbers.
Nice.
So if you came up with another solution, we'd love to see it down in the comments.
And now my brain's all warmed up. I'm ready to learn about lattice multiplication, whatever that is.
All right, so I want to talk just a little bit about the multiplication algorithm and why it works. So we did this in our last video. We would do 24 times 13. So we did 4 times 3 is 12. We carried the 1. 2 times 3 was 6. Plus 1 is 7. We would then put a 0 here. 1 times 4 is 4. 1 times 2 is 2. And then we would add. 2, 11, carry the 1, we get 3. So 312. 24 times 13.
That's how I learned to multiply.
Okay, so let's just see geometrically what is going on when we do that. So I have this rectangle here which happens to measure 24 by 13, and I'm going to chop it up by breaking apart the 1s and the 10s. Okay, so 20, I'm just going to slice right there so that this edge, you've got 20 and you've got 4 left over. For the other side, I'm going to break it down into 10 and 3. So now we've got 4 different regions, and we should be able to find the area of each of those regions pretty quickly. 20 times 10, so that would be 200. 4 times 10 is a 40. 3 times 20 is a 60. And 3 times 4 is a 12. If we add up the 4 rectangles there, the total area should equal 312 units if we have done it right. So really quickly, if we add those up, 200 plus 60 plus 40 plus 12, sure enough, that adds up to be 312. And
interesting.
yeah, but those same numbers, the 200, the 40, the 60, and the 12, they actually showed up as part of this calculation right here.
Oh.
Yeah, the 3 times 4 gave us the 12. We did the 2 times the 3, that gave us the 60. Although we added those together. The 60 plus the 12 is where we got the 72.
Ah.
And this 200 and the 40 is where we got this 240. So anytime we're using the usual algorithm, we're actually just adding up the areas of a bunch of smaller regions. It's just hidden behind the machinery there.
That's kind of cool.
Yeah. All right, Science Mom, we're going to learn lattice multiplication since you asked what it was. We're going to multiply 672 by 46, and this is just another way of doing the accounting, of keeping track of this product. So 672 times 46. And we're going to just multiply rows by columns and get numbers, but I'm going to subdivide each of these little squares into 2 little slots. So 2 times 6 is 12. I'm going to put the 1 here and the 2 here. So I'm going to write my number 12 that way.
Okay.
2 times 4 is 8. I'll just put a 0 and an 8. 7 times 6, 42.
42.
Okay, 7 times 4.
28.
6 times 6.
36.
And 6 times 4
is 24.
is 24.
I gotta admit, I'm a little confused about why we're doing this.
Seemed a little weird. Okay, now we are going to add down each diagonal in this direction. And that's going to give us our values.
Really?
So if I head down this way, okay, so I'm just going to get a 2. 8 plus 2 plus 1
is 11.
It's 11, so I'm going to put the 1 here, and I'm actually going to carry the 1 up there. All right, 0 plus 8 plus 4 plus 6. So that's 18 plus 1 more is 19. And then carry the 1 up here. 2 plus 4 plus 3 plus 1 is 10.
Yep.
Okay, so I'm going to put 0 here, carry the 1, and we're just adding down in this direction each time.
And then we get 3.
All right, and 2 plus 1 is 3. I'm going to put a comma there, and there's my answer. 30,912.
Serious? Okay,
I'm serious.
How does this work?
How does this work indeed? Well, it turns out the way that we have our place value determined, just by the very nature of how we have organized things, all of these digits are in the tens place. All of these digits are in the hundreds place. We got the thousands digits, and then finally, the 10,000 digit. So if we were to do 600 times 40, that would be...
Oh, 600 times 40 is... 6 times 4, 24. 24,000?
24,000. So this 24 here is actually a 24,000. The 20,000, because it's the 10,000s diagonal, and then the 4,000 is in this thousands diagonal.
Oh, wow.
Yeah.
Okay.
So by arranging our work in this order, we are actually grouping each place value along these diagonals. And will this work every time? Yes, it will.
So that's lattice multiplication.
That's lattice multiplication. Okay, Science Mom, I have this weirdly shaped region where I've got a rectangle, when it looks like maybe a rectangle cut out of it. We want to find the area of that shaded region.
Oh, I know. We just need to find the area of the big box and then subtract the area of the smaller Skewampus box.
Aha.
Aha.
Very nice. That's exactly right. So we want the area to be the big box's area minus the small box's area.
Yep.
And if we can just figure out both of those separately, we can plug them in and get this. So how would we get the area of that big box?
Height times width. 25 times 15 for the big box.
Okay. And how would you do 25 times 15? Can you think of an easy way of doing that?
I suppose you could do 20 times 10 plus 5 times 5. Is that legal? Is that right?
No, that doesn't work out quite right. But it was a nice attempt.
Thank you.
So I was actually thinking we're pretty good at handling money, 25-cent pieces, quarters. If you had 15 quarters, my guess is you could figure that out in your head how much that is.
15 quarters would be $3.75.
That is correct. So I'm going to just go ahead and write that. This is 25 times 15 minus, and then the other one, we've got 5 times 12. Okay, and then you said this one was 375?
Yep.
Minus 5 times 12?
60.
For a grand total of 315.
Yep.
Cool. So we have found our area. Usually we would have to try to write out 25 times 15 either using the usual algorithm or we could try lattice multiplication. Just for fun, now that we've answered the problem, let's go back and try lattice multiplication with 25 and 15. 25 times 15 here, let's do it. 5 times 5?
5, but I'm going to write that 0, 5 because there's no 10.
Okay, so you were doing 5 times 1?
Yep.
Okay, and
what
5?
You asked me 5 times 5?
That's
okay. 25.
5 times 5 is 25. I like it. All right, 2 times 5?
Is 10.
And 2 times 1?
2, which we write as 0, 2 because there's no 10.
I like it. Okay, and now we're just going to be adding downward along each of these diagonals. Okay, so when we do that, we just get a 5. 5 plus 2 is
7.
7, and 0 plus 2 plus 1
is 3.
3. There we go.
It
375. It does work. All right, in this problem, it's a little more complicated. We're trying to plant some sod, so some grass. It costs $3 per square meter And we want to know how much is it going to cost to plant sod on this lawn right here. So how would we do a problem like this?
I think the easiest way would be to break up those rectangles into other pieces.
And what are you going to do with those?
Then we're going to multiply and then add them together.
So you want to get the area, and then once you had the area of the green region, then what?
Then we just multiply it by 3.
Okay.
So we need to find the area, and we can find the area either by looking at this big box and subtracting out that.
Okay.
Or we can break it into 2 boxes, and we get the area of this box plus the area of this box.
Okay, I like it very much, Science Mom. Let's give this a try.
Okay.
All right, so let's go ahead and maybe do the second suggestion, where we chop it into 2 different rectangles. So our area would be, so if we've redraw these lines, so now it's 10 by 5 there. This one's only going to be 15 left over, because we had 10 along this side. And
10 plus 15 is 25.
Okay, and for the total height?
7 plus 5.
Is 12 meters. Okay, so there we are. So basically I've got a big rectangle plus a smaller rectangle. So that was 15 times 12. I'm just leaving the units off for the moment. Plus
10 times 5.
10 times 5. All right, so 15 times 12. Well, I know 15 times 6 is 90, so I double that. I'm up to 180.
Oh, that's a cool trick.
All right, plus, and then 10 times 5 is 50. So we get a grand total of 230. And what are our units on this?
Meters squared.
That's right, because we're multiplying meters times meters. We're going to get meters squared. So our total area will be 230 square meters, and it's going to cost $3 per square meter. So the total cost then is that 3 times the 230 meters. Okay, so 3 times 230, and so this one, which is fortunate, just works out so nicely. We're going to get 690. We don't have to break out any special algorithm because the numbers were so small in each place value.
But what if you can't do 3 times 230 in your head?
Yeah, then you've got to break out some algorithm. Lattice multiplication would work, or that area model that we had done, or the usual multiplication algorithm.
Or the usual 230 times 3.
That's right.
Like that.
Exactly. All right, so final answer here is what, Science Mom?
$690.
Okay, yeah. And
which is expensive.
It is pretty expensive, but...
Should have gotten rocks.
I will mention, anytime you've been given a story problem, your answer should be a sentence. If they ask you something, if there's a full sentence worth, you've got to answer in a sentence, and make sure you're including the units as part of your answer.
So $690 is what we need to say down there?
It will cost $690 to plant sod.
That is the answer.
All right, Science Mom, it's your turn to demonstrate that you understand what we've covered today. So in this problem, you're going to show how finding the area of this rectangle is the same as multiplying 16 by 22.
Ooh.
And that's 16 units tall and 22 units wide.
Okay, so I have 16 tall and 22 wide. And I'm going to change colors real quick here because I think it's a little easier if I break it up by color.
Okay.
So 16 is the same as 10 plus 6.
I agree.
And so if I draw a line here and have 10 and 6, that's one way to think of 16. 22 is the same as 20 plus 2. And for this one, I draw my line way over there because 20 is a lot bigger than 2.
Yes, it is. Okay, so now are you going to find the area of each of those 4 rectangles?
Oh, yes, I can. So this one right here is 20 long and 10 tall. So 20 times 10 is 200. Is this what you wanted me to do?
Yep, so that one has an area of 200 square units.
Yep, and then this one right here is also 20, but it's times 6, which equals 120.
Very good. And
then
you're not going to have enough room to write all that in this next box, but...
No, I'm going to, for these these ones, I'm going to draw out lines. So I have 6 times 2, which is 12, and then I have 2 times 10, which is 20. And now if I were to add up this and these, that is going to be the same as doing the traditional 22 times 16 and writing everything out.
That's right.
So if I just add those together, I'll get the answer. So we have 200 plus 120 plus 20 plus 12, which is 1, 2, 3, 4, 5.
Okay.
352.
352 is correct.
Woohoo!
Nicely done, Science Mom.
Thank you.
And if we were to take the time to do 16 times 22, we'd come up with the same answer.
Whether we do it the traditional way or that crazy lattice multiplication way, it's all the same.
Lattice multiplication. What is 512 times 256, Science Mom? We're going to do this using lattice multiplication.
Okay,
So
I can do this.
Draw out that big 3x3 grid now.
Okay, so I've got it set up so that I can multiply 512 by 256, and I'm going to start down here with my 6 and multiply it by 2.
Okay.
And I get 12.
6 times 2 is 12.
And
Good.
I always put the 10 digit up there and the 1's digit down there.
Good.
5 times 2
10.
is 10. 2 times 2 is
4.
4. And now we are on to the next row. So I'm going to have 1 times each of these. So starting with my 6, 1 times 6 is 6. 1 times 5 is 5. 1 times 2 is 2.
Good.
And then 5 times 6 is 30. 5 times 5 is 25. And 5 times 2 is 10.
Good.
And now for the fun part, I just need to add diagonally and down.
Okay. Can she do it?
Can I do it indeed? So 2 plus nothing is 2.
Good.
1 plus 6 is 7. 5 plus 4 plus 1 is 10.
Good.
And if I have a 10 here, I can't just leave the 10 down there. I've got to split it up and carry the 1 just like I would in regular multiplication. So this becomes a 0, and the 1 goes in this diagonal row right here.
Good.
And I'm going to add them together. So now 1 plus 3 is 4, plus 5 is 9, plus 2 is 11. And again, I put the 1 here and carry the 1 up here.
Okay.
So that then it becomes part of this column. And 2 plus 1 is 3. And then our last but not least, 1 plus nothing is still 1. That's what I meant.
You're number 1 in my book, Science Mom.
Thank you.
All right. So our final answer is?
131,072.
And that is correct. Well done, Science Mom.
Phew.
We call that lattice multiplication.
A special thank you to our patrons who make this video possible. Don't forget that down in the description there is a link to a worksheet you can download. It's a free download and you can practice these problems and do additional ones.
And for patrons, there's even a solution file.
Work hard, grow smart, and we'll see you soon.